A ladder 17 feet long rests against a vertical wall. So here is the ground and this is vertical wall, and we got a ladder which is 17 feet long. And if the bottom of the ladder slides away, so the bottom of the ladder is going away, and I'm assigning x variable for this direction and y for this. If the bottom of the ladder slides away from the wall at a rate of 1.2 feet per second, so this one is sliding away, so dx over dt is 1.2. How fast is the angle between the ladder and the ground? So ladder and ground, so this angle, let's say theta. How fast means rate, so we want to find rate of change of that angle that we said theta. So d theta over dt is what? At the moment when the bottom of the ladder is 8 feet from the wall, so when this distance is 8 feet, so I should say this x, okay, when this is changing, and x, okay, y, okay, it's not given anything, we'll see. So somehow we need to involve the 17 theta and x, but at the moment when x is 8, we might be able to find the location y. So when x is 8, we can find y. Now this is a right triangle, that means x squared plus y squared equals 7 squared. From that we can determine the value of y, or we can use other trig identities to find y as well, but the easiest is when x equals 8, since we have x squared plus y squared equals 7 squared, let's find y. Okay, x is 8 squared plus y squared equals 17 squared, that's 64. 17 squared 289 minus 64, 225, take a square root, so y is 15. Okay, this ladder is sliding away, but at the moment when x is 8, when the bottom of the ladder is 8 feet away from the wall, then this distance, okay, this top is falling down, this distance is 15 feet, so we might have to use this later. Now we are asked to find the rate of change of this angle theta. Okay, so we need to involve 17. Now we know y as well, or x. Let's use one of the trig identity that involves x 17 or y 17, or because dx over dt is given, so we want to definitely use x. Y might not be needed. Okay, x and 17, so this is like base hypotenuse. So base hypotenuse means we need to use cosine. Cosine theta is x over 17. Now that is same as if we cross multiply, I mean cosine theta means cosine theta over 1. So this is same as 17 cosine theta equals x. Okay, now let's find derivative of both sides with respect to t. So I'm taking derivative with respect to t of both sides, that gives 17 times derivative of cosine is negative sine theta times, from the chain rule, d theta over dt equals derivative of x dx over dt. Now let's plug in the given numbers or rates and then find the others, find the remaining. So 17 minus sine theta. Okay, sine theta, okay, we good thing we already found y, and from this we can find sine theta. At the moment when x is 8, sine is opposite over hypotenuse, so y over 12, that is 15, sorry, y over 17, not 12, this is 17, so that's 15 over 17. So we will be using that here. Okay, negative 15 over 17 times d theta over dt. I mean, this is what we are looking for, and dx over dt is given 1.2. Okay, and now we can simplify, we can isolate d theta over dt. For some reason here 17 times negative 15 over 17 we can cancel, that leaves negative 15. So now divide both sides by negative 15, so d theta over dt equals 1.2 divided by negative 15. Okay, it will be very small here, that is negative, and this is angle, so angle some number which will be radians per second, right? Radians per second, yeah, that will be radian per second. And let me use my calculator to determine 1.2 divided by 15, that's 0.08. Okay, final radian, angle radian per second.